This is a short lecture on the different models of our solar system. Aristotle was a Greek philosopher that lived around 350 BC. He thought our solar system was geocentric. Geo is a root word meaning earth. Centric is a root word meaning centered. So he thought the earth was the center of our solar system. Therefore, the sun and all the planets would revolve around the earth. He was not alone in his ideas. Claudius Ptolemy came about 500 years after Aristotle. The problem with Aristotle's model was that when we look up at the night sky, night after night, we see Mars traveling east for a while, and then for a few days it'll go west, and then it'll go back east. So it's hard to explain why it's going back and forth. So Ptolemy came up with these epicycles. He said that the planets have two motions. One is this circular motion, and the second is the revolution around the Earth, which gives the planet an illusion that it's doing sort of loop-de-loops. Even though he was inaccurate and epicycles really don't exist, he was able to accurately predict when and where a planet should be in the night sky. This made his model a little bit more believable. Nicholas Copernicus came about in the 1500s. He was the first person to really challenge the geocentric model. He came up with the heliocentric model. His ideas were not very well accepted, so his book actually was not published until a year or so after he had passed away. So his model, the heliocentric, helio means sun, centric means center, so the sun was the center of the solar system. Even though he was right in this model, the problem he had is that he thought the planets were all orbiting in perfect circles, which they are not. Instead, they're moving in slight ellipses or oval shapes. Galileo Galilei, he used the telescope to get very accurate observations and measurements with the planets in the night sky. So with his accurate observations, he helped prove Copernicus's theory correct. Johann Kepler, he was a German astronomer, and he developed 3 laws that govern planetary movement based on the heliocentric model. His first law is the law of ellipses, the second law is the law of equal area, and third law is the law of periods. Kepler's first law states that the planets move in paths called ellipses or oval shapes. This is determined by 2 points called a focus or foci, one point being the sun. Because planets move in elliptical orbits, they're not always the same distance from the sun. So part of the year they're at what is called the perihelion, which is part of their orbit where they're closest to the sun. The second part of the year they're at the aphelion. Ap means away, so it is the point where it's farthest away from the sun. So here we have 2 foci. One is the sun, and this gives the planet an orbit of an ellipse. So at this point of the orbit, it is at its perihelion, closest to the sun. At this point of the orbit, it is at the aphelion, which is farthest away from the sun. Depending on how far apart the foci are, will give you a different level of an ellipse. If the eccentricity is 0, you get a perfect circle. The farther apart the foci become, the more elliptical or eccentric the oval shape becomes. Remember, gravity has 2 factors. One of those factors is distance. So when the planet is closest to the sun, in other words, when it's at its perihelion, it's going to experience more gravity and it is going to move faster. When it's farthest away at the aphelion, it's going to move slower. So the closer the planet is to the sun, the faster it's going to move. Kepler's second law is called the law of equal area because the area in this shaded region equals the area in this shaded region. So even though this area is squished and this area is elongated, they actually have the exact same area. So he's saying that the time it takes for the planet to cover this area is the same amount of time it takes the planet to cover this area. So this is a greater distance, same amount of time. Shorter distance, same amount of time. So this would be like going 100 miles in 1 hour versus 50 miles in 1 hour. So this is going to be moving much faster. Moving on to Kepler's third law. Kepler's third law states that the squares of the periodic times are to each other as the cubes of the mean distance. So this gives this the equation. However, these are subscripts, but they should be superscripts. So it should be r cubed equals the period squared. So in other words, the closer the planet is to the sun, the faster it moves, thus the shorter its period, which means the shorter its year. So if we take a look at the planets, Mercury is the closest planet. It has the shortest radius, and therefore the shortest period. Neptune is the farthest planet. It has the longest radius and the longest period. So Mercury takes about a quarter of the time to go around the sun that we do. And for every 1 year that Neptune has, Earth has 165 years. Newton also helped in the heliocentric model by providing math. First, he developed inertia, or came up with the idea of inertia. This states that an object moving in a straight line will stay in a straight line unless acted upon by an outside force. So this means the planets are never going to stop moving unless they're forced to by something else. Also, he defined gravity as the attractive force between all objects in the universe. There are two factors that affect gravity: mass and distance. So the closer you are to a very massive object, the more gravity you're going to experience.